Hi everyone, let's do today's Leetcode daily challenge problem together. So the question is add digits. Given an integer norm, repeatedly add all its digits until the result has only one digit and return it. Okay. So the question is saying that if the number is 38, then I need to add these two digits together. If I add it, then it will be 11. Then I need to add this one as well, 1 and 1 2. So I should repeatedly add all the digits until I get only a single digit, right? Suppose if it was 101, then if the number was 101, then I would have added all the digits together. It would be 1 plus 1 2. So the result is so we got this number at once, right? Suppose if this was 9, then it would have been 9 plus 1 10. So I would have added 1 and 0 again. Now it is a single digit, so the answer is 1. And constraint is that number, it should be 0. Okay, sorry, not it should be, but it is, the number can go from 0 to 2 to the power 31 minus 1. So it means that there will not be a negative number, but it can be 0. Okay, like given in this example. And could you do it without any loop or recursion in O of 1 runtime? Oh, nice. Okay, so there is a for loop question as well. Let me first think about the brute force solution. So like I did before, obviously I think I would first of all create a loop, right, to add digits. If there are like 1 0 9 1 4 5, suppose this is the digit, then I would first of all get, what I would do is I would just create a loop and then I would add all the numbers, all the digits in this number, right? So first of all, let's say I start at 1, then I would add 1 with 0 9. I just drawn a loop and then I would add all the numbers together. I would do that until I get a single digit number, right? So that would be my brute force solution, and the runtime complexity would be O of n, where n is the time complexity of that solution would be O of n, where n is the number of digits. But the follow-up question is that they want me to solve it in O of 1 runtime without any loop or recursion. So how can I do that? This is an easy question. How can I solve this without any loop or recursion in O of 1 runtime? Interesting. 1 0 9 1 4 5. Obviously I would need to add all the digits. Do form a sum. So without any loop or recursion. Interesting question. Amazon has asked this 4 times and Apple has asked 2 times. Like, the thing that I'm not understanding is I need to look at all the digits once, right? If I do not go through all the digits, then how can I add all the digits to create a sum? Because I need to add all the digits and create a sum until that sum is just one digit. So just in O of 1 runtime, O of 1 runtime means however the number, like even if there are like millions digits in the number, then the runtime would still be O of 1. Then it would not affect the size of the digits wouldn't affect the wouldn't affect the amount of time that I take to solve the algorithm. Interesting. How can I add the digits? I'd be really embarrassed if I cannot think of the solution, because this is easy and I've already spent 5 minutes. So 1091453. So how can I add it? Like, maybe should I use kind of mathematics, bit manipulation or something like that technique, like bit shift or something like that? So if I'm doing a bit shift, then what is, I have forgotten the concept of shifting. So if I'm doing a bit shift, left shift, then it would be I'm really out of ideas here. How can I do without any loop or recursion? Because to get all the numbers I need a loop. Okay, think. I think that there is something. Okay, 10914. So if there are this number of digits, then how can I add all the digits without using a loop? Without using a loop, I'm very tempted to look at the solution, and I give up to the temptation. Oh, logarithmic? Are they using something like logarithmic or what? Hint 1. A naive implementation is trivial. What are all the possible results? Hint 4. How do they occur? Periodically or randomly? The digital root, the repeated digital sum of natural number in a given radix value obtained by iterative process of summing digits on each iteration using the result from the previous iteration. The process continues until a single digit number is reached. For example, in base 10, the digit root of the number is 6 because the sum of the digits in the number is let end with a natural number. Then what are they doing here? So they are using a loop here. Logarithmic time solution is easy to write, although the main question is how to fit into a constant time. Yes, the question is how to fit into a number. So this is the kind of solution that I was thinking here. While number is greater than 0, then I'd find a remainder and then continuously add it. If number equals to 0 and digital root is greater than 9, then I would do number and then continuously add it, right, until there is a single digit. But how to find a, so this is not a like linear time, this is a logarithmic time solution. How is this a logarithmic time solution? Because I need to go to all the digits, right? I need to look at all the digits. Let's see. Mathematical digital root. So what is the solution? Oh, what am I doing? I did not understand in the first place. So before looking at the solution, I'm looking at this solution, like how is this a logarithmic solution? How is this a logarithmic solution? Why is this a logarithmic solution? Number divided by 10, because I'm looking at all the digits. If I'm dividing it by 10, then it would be, I'm just looking at all the digits, right? All the digits in this number. Now I'm divided by 10. If I'm dividing 899 divided by 10, then the answer would be 89. So I'm letting every, all the LSU and what is the other number, least significant digit and most significant digit. So this is the most significant, or this is the most, and this is the least, right? So I'm letting go of least significant digit every time in every loop. So yeah, it should have been O of n, but I do not understand why it is logarithmic time solution still. Anyway, not anyway, I was thinking anyway, let's look at this, but I think I want to know why is this logarithmic solution. So let's logarithmic. Oh, there is no tax in logarithmic. Logarith. Comments. So this person also did it in the similar way. And the inner while do n operations according to n. So after the inner while, you have n 9m. So after the while, the next length will be log n. Oh, that's why I understand it now. So it's like add digits log n plus n operations. Log 10 is equal to 1. So every number less than sorry if there are some mistakes, but I'm having lunch. So a better definition may be of n times log n, I think. And log I can be replaced by log into iterated logarithm. Just remembered me about union find. Anyway, I think that what they are saying is, so if there are like 1 2 3 4 5 6 7 8 9 10 11 12 13 14, there are 14 numbers, then next time when I am adding this, then the number will be it will reduce, right? It will reduce to some maybe log of, will it reduce to log of n? So what is log of n? What is log of n? If log of n is equal to x, then what does it mean? Then it means that n is equal to 2 to the power x, right? So suppose if 8 is equal to 2 to the power 3, then log of 8 will be equal to 3. So it means that if there are 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, so if there are 8 digits and if I am dividing it by, so if the log base is 2, then what log means each is that if I am splitting this these 8 numbers into 2 compartments each, then how many groups will there be? 1 2 2 to the power 3, 2 to the 4, 4 to the 8, then it will be so if I am dividing this, then it will be 4, and then if I divide it more, then it will be 2. So log of 8 is equal to 3 means that log base 2 of 8 means that if there are 8 numbers, then if I am dividing it by 2 continuously, then how many after how many time does it become equal to, after how many iteration will it become equal to 1, right? So if this is 8, then if I divide into 2 halves, then it will be, since the base is 2, so I need to divide it into 2 halves. So if I divide it into 2 halves, then it will be 4 for each. Then if I divide 4 into half again, then it will be 2. If I divide 2 into half again, then it will be 1. So after 3 iterations, it will be equal to 1, right? So it is like 2 to the power 3. So 2 times 2 times 2, right? So if I divide 2, then it will be equal to 4. Then if I divide 2 again, then it will be equal to 2. If I divide 2 again, then it will be equal to 1. So it means that I need to divide by 2 1 time, 2 time, 3 time to get to 1. So it means that I need to divide 8 by 2 3 times. So this is what it is called. I need to multiply 2 by 2 3 times to get to 8. So it is the same thing opposite. So if I multiply 2 3 times, then I will get 8. And if I divide 8 by 2 3 times, then I will get 1. So that is what log means. So suppose if there was a base of 10, log base of 10, then it means that I needed to divide this number. If log and base of 10, base 10, then it means that I need to divide n by 10 x times to get to 1, or it means that I need to multiply x, this is it, right? Log of n, log means dividing. So 8 is equal to 2 to the power 3, n is equal to 2 to the power x, and here log of 8 is equal to 2, 3 base 2. So power means multiplying. So power means multiplying. So I will multiply 2 by 2 by 2 3 times. Power means multiplying, but log means dividing. But it is not a simple multiplying and dividing, right? So it's not like 2 multiplied by 3, it is just once. But this power means multiplying, but that is a power multiplication. It is 2 times 2 times 2. Similarly, log 8 is also division. Logarithmic is also division, but it's like 8 times 2 is equal to 4. Now I need to divide it into 2 half, into the half again. So since base is equal to 2, so I will divide it by 2. right? So if there are 8 compartments, then I will divide it into 2 compartments. Suppose if base was 3, then I would have to divide this 8 by 8 to 3 compartments, right? So since base is 2, so I divide 8 to 2 compartments. So now the answer is 4. So now I will continue to divide 4 by the base 2 again. Now the it equal to 1. If I divide, then it is equal to 1. Okay, so log n is equal to x means, so what this means is, log n is equal to x base 10 means I will divide n by 10, right? It means that if there are n compartments, then I will divide it into 10, means I'll divide it into 10 equal compartments. So if suppose if it is equal to 1000, 100, then it will be equal to, suppose if it is equal to 100, suppose if it is equal to 150, then it will be equal to 15, right? So I divided 150 compartments to 10 equal compartments, so there will be 15 compartments. So does this mean that there will be 15 compartments? So if I divide 150 divide by 10, and if it is equal to 15, then it means that since I divided into 10 compartments, then it doesn't mean that, sorry, it doesn't mean that there will be 15 compartments, but it means that the size of each of the 10 compartments, it will be equal to 15. So one compartment, because I divided it into 10 compartments, it's like there are 150 chocolates and I need to divide it into 10 children. So each children will get 15 chocolates, right? So 15 chocolate. Now I need to divide 15 chocolate to 10 people again, because there is a group again. There is a small group there as well, so I need to divide them there also. So it means that first of all there is 10 group of people, 10 groups, okay? So there are 150 chocolates and I need to divide it amongst 10 groups. So each group will get 15. Each group gets 15 chocolates, right? Now what we found out, that even in that group also there are 10 groups. So it means that I need to divide it again, right? So 15 divided by 10. So when I will divide that again. (15 divided by 10 is equal to 1.5. It is like 1. So each children will get 1, 1, 1. So each group gets 1. Now I cannot divide this further, right? Because there is just 1. So this means that log 150 of base 10 would be, and the answer would be 2, right? Because when I am splitting amongst groups, to get to the 1, I would need to do it 2 times. Like similarly, log 2 to the power 3 was equal to 8. It is equal to 8 because first of all 8 divided by 2 is 4, and 4 divided by 2 is 2, and 2 divided by 2 is 1 finally. So it's that similar way. So it's like 8 chocolates and 2 groups. So 2 groups. So one group will get 4 chocolate, and there are 2 even in that group. There are 2 groups again. So now 4 divided by 2 is equal to 2. So each group will get each group will get 2, and now again each group will get 1. So even if this group has like 2 or group more, then it cannot be done. Nothing can be done now because this cannot be divided. So the answer is 3. I could only divide it 1 time, 2 time and 3 time. Right, so 8 divided by 2 1 time, 2 time and 3 time. Okay, 2 to the power 3 is equal to 8. So that's it. Actually I also did not know the concept of logarithmic so nicely. I was trying to explain to myself here as well. I think I'm more clear than before here. So it's just like multiplication, power is just like multiplication, and log is just like division, but power means multiplying this number by itself x times, and logarithmic means whatever the base is. Suppose if the base is 10, then logarithmic means dividing n by 10, right? Dividing n by 10 until I get dividing n by 10. So it's like n chocolates and I'm dividing it by 10. So I'm dividing to group. So if there are n numbers, then I'm dividing it into smaller groups of chocolates, like smaller group, until I get just one value. So log means also it is also division. So it is also like n divide by 10, but it's not actually n divide by 10, but it is n divide by 10, continuously divide n by 10 until the value is 1, and know how many iterations it takes. So that is the value of x, right? So 2 into 2 into 2. 2 into 2 into 2. If this is n, then I need to divide it by 2. If I divide it by 2, then 1 goes away, then this goes away, then at last it will be 1. So I need to know. So this x is actually the number of iterations, because here also, while the power also means to iterate these 2 x times. So multiply, so power means multiply 2 x times iteratively. Right? And log means divide n by multiply 2 x times iteratively, and this means divide n by 2 iteratively, and find the number of iteration until get to 1. So I will keep on dividing the space until I get to the value 1. I will keep on dividing it by 2 until I get the value 2. So first of all, this will be 4, this will be 4, and this will be 2, and then it will be 2. Okay, it's like first of all, this is a group, and this is a group, and then this group. It's like a binary, right? Because whenever I'm dividing once, then I'm just ignoring another sort space, because I'm only sorting here only. I'm only dividing this into further sort space. I'm only dividing the one half of the sort space, only one portion of the sort space. Suppose if the base is 10, then first of all I will like divide this into 10 compartments, right? 10 equal compartments, and then I will only look at one compartment in the next time. Then I will, after distributing this to 10 groups, I'll only look at one group now, and then continue to distribute that. Okay, I think this is it. So let's come back to my question here. So that was my, that was how I so what I did just now, I was just trying to understand the logarithmic, what logarithm means. And now let's see why is this time complexity logarithmic here. Because here also I am dividing this by 10, right? I am dividing this by 10, and it will become, so whenever I divide this number by 10, then it will be 1091,434. And I am dividing this again, and I am dividing this again, I am dividing this again, I am dividing this number again. So it's like I am doing this until I get so I'm dividing this number by 10, and I get some number, right? And I divide it by 10 again until I get a single digit. Does that mean some kind of logarithmic solution? Is that on logarithmic same? Like if I am getting some, if I get some number and if I continuously divide, so if I get this number and if I divide it by 10, then it will be like I said before, if it is 15, 150, then if I divide it by 10, then it will be 15. So if I divide 15 by 10, then it will be 1.5, like similar to 1. So until I get 1. So the number of iterations, like it takes 3 iterations, right? Okay, yeah, makes sense. So it means that whenever I am creating a while loop, right? So I'll always look if n is greater than 1, right? Whenever I am creating, so n will be equal to n divided by 10. So it means that how many times the iterations happen, how many times the iteration happens, that is what log is, right? So because that is what the logarithmic, so log n is equal to x, so this gives the value of x. Find the number of iteration until it gets to 1. So how many times the iteration happens, that is equal to, so suppose in this case until it gets to 1, so it is like it's like log of norm, log of the number that is given, 38. if this is a number, then sorry actually I'm confused here, but okay. So the time complexity is equal to log of this number, because if I do log of this number, then it will give me, you know, the number of iterations base 10, number of iterations until I get 1 to 1 when I divide it by 10. So yeah, and isn't this equal to the number of digits? Because that's what, like I was saying in the beginning, it is equal to the number of digits. Isn't this equal to the number of digits? Anyway, so I think that I understood why they are giving this log value here. It is a logarithmic solution, that's why. Let me try to find the same solution again. I will never fall in love with you till I fall. It's easy to write. I just realized that I have not even looked at the main solution. Na 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 na. The inner while do n operations according to the length of the number is equal to n. At first you have suppose numbers composed of 999. So after the inner while you have 9n in num, then the length of 9n is log of 9n. Yeah, see, that is equal to the log of 9. Okay, I think that the length of is equal to log of 9 of n. Okay, so it means that is true, like this is equal to the length of num. So if this is also a one way to find length of number, right? That is log of that number, I mean length of sorry. So I just found one formula, I think. Length of num is equal to log base 10 of num. So that will give us a length of num. And so after the while, the length next length will be log of n. Suppose you do it recursively. So the recursion of add digits n will be equal to add digits log of n plus n operations. Anyway, I think the log of 10 is equal to 1. Log of 10. Okay, I think I got this approach. This is how it is log. Solution. Though I am not fully clear, but I think I will settle on this. At least I knew, you know, I got new knowledge here, this formula. And mathematical digital root, formula for the digital root. So there is a known formula to compute a digital root in a decimal numerical system. How to derive it? Probably you already know the following proof from school, where it was used for a divisibility by 9. The original number is divisible by 9 if and only if the sum of its digits is divisible by 9. What? The original number is divisible by 9 if and only if the sum of its digits is divisible by 9. Nice. The sum of digits is 0. The sum of digits is divisible by 9, and the sum of digits is not divisible by 9. It is not a must to be bad at math. The hints are useless. Cool maths. Let's understand maths. The last step is to take the modulo from both sides. Digital root in a decimal numeral system. N is equal to d0 plus d1 dot 10 to the power 1. Nice. N is equal to this one, right? dk into 10 to the power k plus d squared d2 into 10 to the power 2 d1 into 10 to the power 1, right? This is the same. This plus 5 into 10 to the power like 154. What is 154? It is 1 into 100 plus 5 into 50 plus 4. One could expand its power of 10 using the following. So 10 is equal to 9 into 1 plus 1, 99 plus 1, 999 plus 1. So 10 to the power k each 100 k times is equal to 99 k times plus 1. So the result is n could be simplified as, okay, nice. The last step is to take the modulo from both sides. So modulo of 9 is equal to this modulo of 9, and to consider separately 3 cases. The sum of the digits is 0. Actually, if someone is watching my video, then please have a look. So I'm just moving my cursor very slowly so that you guys can have a look here, because I'm not looking at the solution now. So I'll start from here, moving cursor here, and let me show the code also. Okay, this is the code. That's it. I'm not looking at the solution because I don't think that it's necessary at this point. Okay. I'm just thinking if I should code this O of logarithmic solution or not, because it's already 43 minutes in the video. Okay, let me do it very quickly. So it's like result is equal to, I need to return result, right? So if result is, let me first do this. So while number and number is equal to, and result will be equal to result plus norm percentage 10 in the beginning, and then norm will be equal to norm divided by 10. So if it is like 1 2 3, then it will be 1 to divide by 10 will be equal to 1, and 1 divided by 10 will be equal to 0, right? 1 divided by 10 will be equal to 0, isn't it? 1 percentage 10 will be equal to 1, but 1 divided by 10 will be equal to 0, I think. Yeah, so while norm is there, I am doing this, and if so when I finished all the number, then when I'm done with 1 2 3 4 1, then there will be a result, right? So if result is greater than or equal to 10, then it means that this is a single multiple digit, so norm will be equal to rest now, and then I need to loop here as well. While res is greater than or equal to 10. Equal to 0 in the beginning. Find the result of adding numbers. Add all digits, number. So sum will be 0 in the beginning, and then while there is a number, then it will keep on adding. Sum is equal to sum norm percentage 10. Return sum at last. Okay, so add all digits. This is equal to result. Actually this can be called a norm only. And while norm is greater than or equal to 10. Just trying to keep different variable here. So yeah, so if number is, and at last return number only. So if number is 0, then only if number is greater than or equal to 10, right? So it will just return 0. If it is 9, then it will just return 9 only. But if it is greater than or equal to 10, then it will add all digits. So suppose if it is 1 0, then it will add, and num will be 1 now, and it will return 1. Yeah, I think this should work. Oh my god, output is 4. Why is the output 4 here? Oh, 12.22, what? Eight, 9, 10, 11. Add all digits and sum is equal to 0 in the beginning. So while there is n, yeah, I think this is some kind of, while n, so in the beginning it will be 38, and sum is equal to sum plus n percentage 10, right? So n is equal to 38, and 38 percentage 10 will be equal to so when I divide 38 by 10, then the remainder will be equal to 38 divided by 10. 10 3s are 30, and 10 3s are 30. Remainder will be 8, and the quotient will be equal to 3, right? So that's what it should be. This should be equal to 3, and this should be equal to 8. So sum should be equal to 8 here, and this should be equal to 3. So next time when I divide 3 divide by 10, then remainder should be 3 only, and the quotient should be, what is the quotient? When I divide 3 divide by 10, then quotient is equal to 0, right? So it will be 8 plus 3, 8, 19, 11. Yeah, I don't know why this is happening here. Let's console that log n here. 38, 3.8. Oh, what is happening? I think that I was just considering that n is equal to n divided by 10 will return the quotient, but it will not. It should be math.floor n divided by 10. Okay. Okay. Yeah. Mistakes like this. So n divided by 10 wouldn't give me the quotient. It will give me the exact value. Okay, I think I should sign off now. Thank you for watching till now. If you have made it so far. Thank you. Bye.